extra practice. We'll start with number 3. We'll do a few problems where we have to find the inverse, and then a couple problems on the back where you have to verify or decide if two functions are inverses of each other. So let's start with a linear function here. Number 3 is h of x equals x plus 7 all over 3. So remember, when you start this problem, this h of x right here is really a y. And it even says in the directions, when you're finding an inverse, you have to switch the x and y values. So you'll start here by taking that x value and that y value, those variables, and just flip-flopping their location. So you'll have x equals y plus 7 all over 3. Now, our goal here is to get another function h of x, which means we have to get y equals again. So to start, you need to move the 3 out of the denominator. You cannot touch the numerator until that denominator is gone. To move that denominator, you're going to multiply both sides by 3 and get 3x equals y plus 7. And there's only one more step to get y by itself. You need to subtract 7 from both sides, and you'll get 3x minus 7 equals y. All right, remember, we want to use formal inverse function notation, so that y here is going to be written as h inverse of x. That would be the inverse function of the original h of x. All right, that one should have been pretty simple. That's linear. Let's move on to one that's a little bit more challenging. Let's do number 8. Number 8 has a square root in it. We have y, y equals 2 square root of x plus 5. So to start this problem, again, you need to take those x and y values and flip-flop them. So you'll have x equals 2 square root of y plus 5. Now, before you can get to the square root, you cannot access the square root until you move the 2. Sorry about that, guys. Here we go. So in order to get to the square root, you need to start by dividing both sides by 2. That makes that coefficient go away, and you get the fraction x over 2 equals the square root of y plus 5. Now we have the square root as the next thing we can get. We have to move before we can get to the y value. All right, we have to start farthest away from the y. That's why we started with the 2. Now we have to move to the square root. The way you undo a square root, or the way you get rid of it, inverse it, is to square both sides. Now be careful on the left. The reason I chose this problem is because on the left you have to square the entire quantity, x over 2, not just the x. So when you square that quantity, you square the x, which is x squared, and you square the 2, which is 4. So you have x squared over 4 equals, now y plus 5. You could not access the y or the 5 until you got rid of the square root. We've done that, so our last step here is to subtract 5 from both sides. That gives us x squared over 4 minus 5 equals y. Now we need to use formal inverse notation here. Since our original problem started with a y, the way we'd write the inverse is just to add the little negative 1. Y inverse is x squared over 4 minus 5. The hard part about these problems for some of us is that we are doing the square before we're allowed to, so we have to be careful. All right, number 9. H of x equals the cubed root of 4x plus 1. So just like the last problem, we need to start by flip-flopping the x and the y. So we'll have x equals the cubed root of 4y plus 1. Now you are not allowed to access the 4y plus 1 until you get rid of the root that is above it. The inverse of the cubed root is to cube both sides. That's going to make the cubed root go away. It doesn't touch anything underneath, it just makes the cubed root go away. So now you have x cubed equals 4y plus 1. And from here, this should be a pretty simple process. You're going to subtract 1 from both sides and get x cubed minus 1 equals 4y. And then you're going to divide both sides by 4. So your final answer here is going to be x cubed minus 1 over 4. That equals y. But remember, we need to use formal inverse function notation, which would be h inverse of x. Those two functions are now inverses of each other. All right, so we've done some practice with finding the inverse. There are other problems on this page other than the 3 that I did. So if you need to see those worked out, you can check out the key that is posted on Canvas, look at the answers on the back of the paper, or come in and talk to your teacher. Let's talk about confirming whether two functions are inverses or not. And I'm going to do number 11 to start here. Number 11 has a square root and a square in it. We want to decide if h of x and g of x are inverses. To do this, you need to perform two operations. You first need to do h of g of x. The other one you're going to do is g of h of x. We're not just finding the inverse of one and deciding if it is an inverse. We need to actually perform a composition. This is a mathematical proof. So this first one on the left here, we're going to take the function of g and put it into h, which means we're going to take that 8x squared plus 16 and put it into h for x. So let's be careful here as we write this down. We start with a big square root over top. In place of the x right here, we put that entire function, 8x squared plus 16. That is all over 8. Then the plus 2 is not in the fraction. It's just outside. Now, I want you to be careful. Some of us are making the mistake and just crossing off the square and the square root. That is not allowed. You are not allowed to just cross those off. The reason being, partly, as I said in class, there are plus signs in this problem. The plus sign blocks you from being able to just cross off the squares. Yes, it will happen eventually, but you have to do things in the right order. The order really does matter for when you simplify these problems. So the first thing you need to do is simplify underneath the radical. That means we want to simplify this fraction to start. Well, let's think 8x squared over 8 is just x squared. 16 over 8 is plus 2, and then I have an extra plus 2 on the end. All right, now we have to simplify again. I'm still not allowed to just take the square root. So then I would have the square root of x squared plus 4. Now, one final thing, because students were making this mistake again. You are still not allowed to write this, but to take the square root of each part. You cannot say that that is x plus 2. That is not okay. Just like up above, the plus sign in here prevents you from taking the square root of both parts. Mathematically, the square root of two things being added underneath a radical is not equal to square rooting both parts separately. That is not okay. If it were multiplication, then yes, you could break up the square root over the multiplication, but not over addition. So, that being said, this is your final answer. You do not get any more simplified than the square root of x squared plus 4. That is the result of the first composition. Now we have to do the next composition, and that composition is to take the function of h and put it into g. So let's start over here. We're going to take this entire square root and put it in for x in g. So let's write this down. I'm going to start with the 8. Now instead of x, I'm going to put the entire square root of x over 8 plus 2 in this spot. Oop, it's not highlighted, so that didn't really work. In for the x here. Now after the x is a square, so I put a square on there, and then plus 16 on the end. Now in this problem, you are not allowed to just cancel off the 8's. That's not okay. That's not going to work because the square root is in the way. So what you have to do first is get rid of the square root this time. So this time, the square here and the square root are going to cancel each other off. So you'll be left with 8 times x over 8 plus 2 plus 16. Now again, some of us want to just cross off the 8's. That is not okay. You need to distribute the 8 here. Because there's a plus sign, you have to distribute. So when I distribute that, I get 8x over 8 plus 16, and then plus 16 again. Now we can simplify to finish. The 8's will cancel, which gives me x plus 32 when I add these up. That is the result of the second composition. Now, because the results of both composition were not x, these two functions are not inverses. They are not inverses of each other because the results of both composition are not equal to x. So it shows that problem because we need to be careful with when we cancel things and how we simplify. All right, let's try a different one. This one should be a little bit easier. It's two linear functions. We need, again, to do two compositions in this problem. We need to verify by deciding if f of g of x gives us a result of x, and the composition g of f of x gives us a result of x. So to start here, we're going to take g of x and put it into f. So this entire fraction, is going in for x. So to do this, we're going to start with negative 7. Now instead of x, you're going to take the entire quantity, x minus 2 over negative 7, in parentheses for that x. Then add a 2. All right, now there are a couple of ways to tackle this problem. You can go right away if you want to. Cancel off those negative 7's. You're allowed because you are multiplying fractions here. You could cross off those negative 7's and get, x minus 2 plus 2. Those 2's will go away to give you a result of x. That is one way to simplify that problem. Another way some of us like to do, get to it right here, is that some of us like to remember that that negative 7 is over 1, and you're multiplying two fractions here, which means you multiply the numerator by itself, and then you multiply the denominators together. If you do it that way, that is totally fine. You would get negative 7x plus 14 over negative 7 plus 2. And then you would go ahead and simplify the fraction. Negative 7x over negative 7 is just x. 14 over negative 7 is negative 2 plus 2. And then like before, the negative 2 and positive 2 cancel off, and you get a result of x. Either way you simplify that problem is correct because you're multiplying here. Now let's check the other function. This time, we are going to take the function of f and put it into g. So the negative 7x plus 2 is going to go in for x here. So for x, you're going to write negative 7x plus 2. That whole function minus 2 over negative 7. Now you cannot cross things off. You are not allowed, again, to just cancel off those negative 7's. Same reason as before. The plus sign and the minus signs in the numerator block you from doing that at the moment. You need to start by simplifying the addition on the top, on the numerator. So you have negative 7x. Those 2's are going to add away to 0. Negative 7x over negative 7, and now you are allowed to cross those off and get a result of x. Because both compositions give you a result of x, you can say that f and g are inverses. And you just did a proof that said that f and g were inverses of each other. So again, be careful with how you cancel things off. Last problem we're going to do for you here. We have k and j. We want to decide if k and j are inverses of each other. So I'm going to start by finding k of j of x, and then j of k of x. Alright, so when we start here, we're going to take the whole function of j and put it into k for x right here. So we need to be careful again. I start with a square root. The 5 stays the same. Now instead of that x right there, I put a big set of parentheses and write the entire fraction, x squared minus 1 over 5. The whole fraction is in parentheses. And then plus 1. Alright, another big problem that some people are having. Just like before, you cannot cross off the square root and the x. I know you know it's going to go away, but you need to follow the correct procedure for simplifying. In order to start this problem, you need to simplify underneath the square root before you are allowed to cancel off the square root. So just like the last problem, this 5 times the fraction is multiplication. So you are allowed either, you can distribute the 5 to the numerator and simplify the fraction that way, or just cross off the 5's. Okay, I'm going to cross off the 5's for this one. If you want, you can simplify by doing the distributive property. You should get the same answer. Well, when those 5's go away, I get x squared minus 1 plus 1. Again, the next correct step here is to simplify that. Negative 1 and positive 1 becomes 0, and you get the square root of x squared. This is finally when you are allowed to say, oh, that square root and the square are inverses of each other, and your final answer is going to be x. Until that step, you are not allowed to cancel off the square and the inverse. All right, last part here. We need to find j of k of x. This means you're going to take k and put it into j. So that entire square root function needs to go in here, plus my fraction part, for x. Okay, so let's finish this up. So for x, you're going to have the square root of 5x plus 1. It's being squared. You have a minus 1 after the square root. And that is all over 5. All right, now, here, in order to start, the very first step you need to do, before you can deal with the 5's, before you can deal with the 1's, is to get rid of the square root. The square and the square root are inverses of each other. That leaves you with 5x plus 1 minus 1 all over 5. All right, you're not allowed to cancel the 5's yet, but you can simplify positive 1 and negative 1, which will give you 5x over 5. 5's cancel, you get a result of x. Again, because both compositions gave you a result of x, you are allowed to say that k and j are inverses. Check your answers for the other problems. If you are still having difficulty, you need to come and see your teacher. Order does matter in these problems, which is why I've been really particular about how we grade these and how we simplify.